Hello learners, welcome to the week 6 of our first quarter. So our topic for this week is about square roots. So recall that a rational number is expressed as a fraction or a decimal. Every terminating or non-terminating repeating decimal represents a rational number. A square root of a number is a number when multiplied to itself will give you the original number. For example, the square root of 9 are positive 3 and negative 3 because when positive 3 and negative 3 are multiplied to themselves, they are equal to 9. So let us emphasize this. So if you are going to multiply positive 3 to positive 3, the answer would be positive 9 because they have the same sign. And for negative 3 times negative 3, the answer is also positive 9 because the signs are the same. They are both negative. So the square root of 9 could be positive 3 or negative 3. If the square root of a number is non-terminating or non-repeating decimal, we say that it is an irrational number. So every positive number has two square roots. One is positive and the other is negative, as we have discussed before. The principal square root is the positive square root of the given number of or radicand. So meaning to say, we are going to determine the positive square root as the principal square root. The principal root is rational if the radicand is a perfect square. If not, then the principal square root is irrational. 0 has only one square root, which is 0, because if you multiply 0 to 0, 0 times 0 is equal to 0. In addition, negative numbers do not have real square roots. So there are no square roots for a negative number. For example, the square root of negative 1. It is not possible. Their square roots are called imaginary numbers, which are tackled in a higher branch of mathematics. So we are not going to study the imaginary numbers about. So square roots are the numbers that, when multiplied by themselves, for example, if you are going to take a number which is 4, if you are going to multiply 4 by 4, that is equal to the number under the square root sign. So 4 times 4 equals 16, and you would have the square root of 16 as equal to 4. The best you can do is to give an estimate of its value. But for this time, I am allowing you to use calculators for your easiest way of learning. For illustrative example number 1, we have to find the principal root of 49. So I have here a scientific calculator from Google Play Store. So I have downloaded this one since first year college, that is 2013. I already have this kind of application. So this is very usable because you can handle this every time. So this is the square root function or the radical sign, and this is the exponent function of this calculator. So find the principal root of the square root of 49. All we have to do is to click the radical sign, then insert the radicand, which is 49. Then the answer would be 7. So this means that the square root of 49 is either 7 or negative 7, because 7 times 7 is equal 49, and negative 7 times negative 7 is 49. Thus, the square root of 49 has a principal square root of 7, and it is rational. So to check your answer, you have to multiply 7 by 7, then the answer would be 49. If you want to check if negative 7 times negative 7 is equal to 49, just click it down, then equal sign, that is also 49. So that could also be 7 raised to 2 or 7 raised to the second power or 7 squared, which is 49. So the square root of 49 is equal to 7. So for illustrative example number 2, we have to determine whether the principal root of square root of 17 is rational or irrational. So we have to put it in. So square root of 17, that is equal to 4.12, which is irrational. So the radicand, which is 17, is not a perfect square. If the radicand is not a perfect square, then the principal square root is irrational. When we say perfect square, meaning to say that the square root is a whole number and not in the form of a decimal number. For illustrative example number 3, between which two consecutive integers does square root of 6 lie? So we have to form we have to identify two perfect squares, so which are 4 and 9, because 2 times 2 is equal to 4 and 3 times 3 is equal to 9. Therefore 6 lies between 4 and 9. So 6 is greater than 4 but is less than 9. So we have to take 4 and 9 because they are perfect squares. If you are going to put in square root of 4, that is 2. And square root of 9, that is 3. So that is square root of 2 and square root of 3. We have to put in at the middle the square root of 6, which is 2.44 or 2.45. So square root of 6 is being located between 2 and 3. Illustrative example number 4, square root of 75 lies between what integer? So all we have to do is to put it in again. So that is 8.66. So 75 lies between the consecutive perfect squares 64 and 81. How did we know it? So that is square root of 64, that is 8, and square root of 81, that is 9. So that is between square root of 64 and square root of 81. So all you have to do is to make a pattern of perfect square. So let's start with 0 times 0, that is 0. Therefore the square root of 0 is 0. 1 times 1, that is still 1. That is the square root of 1 is also 1. So 2 times 2, that is 4. Therefore square root of 4 is 2. So that 4 is a perfect square. Next, 3 times 3, that is 9. Therefore 9 is a perfect square. Next, 4 times 4, 16 is the next perfect square. 5 times 5, 25 is the next after 16. 6 times 6, that is 36. 7 times 7, that is 49. 8 times 8 is 64. 9 times 9 is equal to 81. 10 times 10 is equal to 100. 11 times 11 is equal to 121. 12 times 12 is equal to 144 or 144. Therefore, we have a lot of perfect squares starting from 0. So we have 0, 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. Then you will be the one to find the other from the other perfect square starting 13 up to whatever you want. So for illustrative example number 5, we have to estimate square root of 10 to the nearest hundred. So again, just input square root of 10, that would be 3.16. So therefore the estimation is 3.16. So we do not have to do the estimations because it will be hard for you, since I cannot explain it to you personally. So illustrative example number 6, estimate square root of 45. Again, just put in square root of 45, that is 6.71. So irrational numbers are found on a number line by approximation. So we can plot an irrational number on a number line using its estimated value. So plot the following irrational numbers on the number line. So since we have a number line, all we have to do is to find the value of the given square root, then estimatedly plot it on the number line. So you have to look at your illustrative example number 7 on page 26. So we have to find the value of square root of 3, which is 1.73. So that is almost closely plotted to 2, but not actually plotted on 2, because that is still 1.73, which is not equal to 2. Next one is square root of 23. So that is 4.8. So that is not plotted on 4, not even on 5. That is plotted before 5, because that is 4.8. We still have to find 4.9 and before going to 5. Square root of next one is square root of 48. So 6.93. So that is 6.93. That is not even on 7. That is not plotted on 7, because we still have 6.94, 95, 96, 97, and 98, 99 before going to 7. So that is how you plot or to find the values of square roots. So for this week, you are going to find the answers for learning task 2 only, which is page 27. So I have given you the output or the answer sheets on our Google Classroom. All you have to do is to edit, because you have your own copy. So you are going to answer A, B, C, D, and E. So for D, you have to edit the attached photo on your Publisher or Word or whatever you want. At least I have given the numbers on the number line. So that would be all for this week, and don't forget to enjoy learning. Here again, your teacher, Sir J.